All right, we're live. Thanks everybody for joining us today. My name is Danny Sloan. I'm on the market management team here at Federal Resources. A little intro on FR. We're a solutions provider to our military, federal government, and first responders. And for decades, we've partnered with industry-leading technology companies like D-Fend Solutions to bring innovative solutions to our customers. And through combining that innovative technology with our procurement vehicles, we work quickly and effectively to get customers or get equipment into our customers' hands. FR has multiple contract vehicles with various scopes and ceiling values where we look to assist our customers with rapid procurement. EnforceAir, which is D-Fend's flagship counter unmanned aerial system product, it detects, locates, and identifies rogue drones in your airspace and then neutralizes the threat by allowing you to take full control over the drone and land it specifically in a predefined zone. The deployment options, including vehicular, tactical, and stationary, make this solution the ultimate CUAS system for operational agility and flexibility with setup, transfer, mounting, and configuration within minutes. For everybody listening on the call, I ask that you take a look below the video here for the request a quote button, as well as the ask a question button. Feel free to use those throughout the presentation. We'll be monitoring the questions and answering them as they come in. Before I turn it over, I've got Terry here with D-Fend Solutions. I want to note that we, one, are looking forward to a great presentation today, but we're also going to have a live demo on March 30th in Maryland. So make sure to follow up with the FR account rep, who invited you on this call for additional information. And with that, Terry, I'll go ahead and turn it over to you.
Hey, thanks, Danny. Appreciate it. Good morning, everyone. What I'd first say is, Danny, look, after this call, if you want to talk about a job with D-Fend after the way you described our system, happy to have that conversation. Well done. But thanks so much for the backdrop and the introduction. I'm thrilled to be here with you, coming to you live from my hotel room in Los Angeles. I'm here this week because we're demonstrating our system at Los Angeles Dodgers Stadium today and tomorrow. I'll tell you a little more about that later in the threat to the stadium environments and how our system is ideal for that type of scenario and environment. But I'd like to talk with you a little bit today after showing you a short video about how prolific the drone problem has become and how counter UAS or counter unmanned aerial systems capabilities like ours are helping defeat the real threat that could result in some damage, harm, or undesirable effect or event. And then what we refer to as the careless or clueless users who buy drones on Amazon without a license, background check, don't go through pilot certification, and are flying them in what sometimes becomes unrestricted airspace. And then we've got a problem there where it could collide with a plane or other types of activity where it might fly into a stadium. So I'll just have a short PowerPoint presentation after a short video that I want to show you right now that kind of captures, if you will, the context of the drone, the proliferation of drones and the damage that they can cause. And it talks a little bit about the types of solutions that are in place and why D-Fend Solutions EnforceAir's capability or solution system, the EnforceAir system, is ideal for the cyber takeover and then safe land and control of the drones. So if you let me here, I'd like to go ahead and share my screen. We tested this, so hopefully it goes well as the testing. So stand by one sec.
Perfect. We get the video there. And Terry, while the video is playing, we don't have audio, so if there's anything you want to call out, feel free to do so.
So here's our system. That's the assembly there. The antenna coverage provides. So in addition to getting the drone in its location, we also get the radio controlled operator's location. All right. Sorry you couldn't hear the volume on that. It's quite remarkable, but hopefully you got the gist of it with the video and the terms being portrayed. Start again, sorry. All right, so I will now share my PowerPoint presentation. Let me know if this is viewable as well. And I'll go through some slides quickly.
Perfect. Yep.
Okay, great. So again, I'm Terry DiVittorio. I'm the General Manager of Defense Solutions North America. I manage all of the Canadian business and the US business. I've been in the job for a little over a year, so I think I'm through my probationary period. But I'm thrilled to be managing this organization for North America, and I'll tell you a little about the company here in a second. But here in North America, we've got a group of folks that work for us here in the Tysons Corner area, or well, back in the Tysons Corner area in Virginia. That's our home location or headquarters in North America. 15 folks there, and we have 4 folks up in the Canadian area in Ottawa servicing the clientele and the vertical markets that we serve there. A little bit about the company. The company is headquartered in Ra'anana, Israel. We have 150 people in the company. Most of them are located there in Ra'anana, where we do the actual development of this capability, a lot of system engineering, a lot of RF tactical communications expertise, a lot of offensive cyber expertise, and that group there develops the software and the hardware that goes into our flagship system called the EnforceAir system that I'll talk about later. The company's been up and running since 2017. Our system is operational today. It's TRL 9, technology readiness level 9, meaning it's operational, tested, and deployed. We're globally positioned around the world, supporting customers in the Far East, Europe, Middle East, UK, Canada, Latin America, and the US. Our system is designed to support counter drone activities for military special forces, where we are downrange in some undesirable countries and areas around the world, providing protection against what terrorist groups like ISIS are doing with drones, flying drones to conduct intelligence, surveillance, and reconnaissance missions, while also using drones to carry bombs and payloads to drop on our troops, consulates, forward operating bases. We're also supporting the border and border patrol agents on the southern borders of the U.S. and the other country borders. We're down in the southern borders where we were last week. The cartels are using drones to courier opioids, fentanyl, marijuana, cocaine across the border as a new delivery mechanism, as opposed to tunneling through or driving across. And for the cartels, purchasing drones in the hundreds of thousands of volume of drones at a very low price is a mechanism by which they're now using to communicate their nefarious activities. We're also supporting airports around the world. That's unknown to many folks that the airports are plagued with drones flying in and around the restricted airspace along the inbound and outbound core air corridors. There have been countless close calls around collisions, but there was several incidents where not only within the United States, but also in the UK, where a drone flying into the restricted airspace closed the airport for a matter of days because of the potential damage it could have caused. So, on the airport scenarios, we're very, very prolific at several airports within the United States, Canada, and then overseas as well. And then we're very big in the law enforcement space and the protective detail space with customers who provide that kind of functionality for several different types of scenarios. So the system has a lot of utility. It's been tested, proven, deployed It's operational in places today. So if you were to look into acquiring a counter UAS system, there's mounds and mounds of data where we've been tested, evaluated, and approved, and there's great references from both commercial and federal customers who've had our systems for several years that you don't have to listen to me. You can take it from them that we're, in fact, developing a very unique capability. So a little bit about EnforceAir, which Danny said is our flagship counter UAS system. It's a premier RF radio frequency cyber takeover technology, and I'll describe that a little bit so you understand what I'm talking about here. But there's three ways to take down a drone. There's a kinetic solution where you shoot the drone with some type of projectile, or you fly another drone into that drone, or you fly a drone and throw a net over that drone. But in a kinetic kind of way, something happens to the drone, and then the drone no longer is able to fly, so it's going to crash. And when it crashes, it could crash into a stadium, it can crash into a building, it can crash into some critical asset, and there's going to be collateral damage. So kinetic is one way to take down a drone. A second way is to jam the frequencies across the frequency spectrum, so that any drone flying at whatever protocol or whatever frequency, its communication signal between the remote control operator and the drone is severed because of the jamming of the frequency. The communication can no longer occur. That's an effective way to take down a drone. However, when you're jamming that frequency between the drone and the radio control operator, you're also jamming all other frequencies in the areas. So if you're at an airport, you're using a jamming system, you're also jamming now the National Airspace System. There are communications between the air traffic control towers and the ground and planes. Security first responder type of communications are now jammed. So although it may counter or mitigate the drone issue or potential threat, it also disrupts all other communications. So not exactly totally effective. The third way to take down a drone, though, is with what we do, which is our cyber takeover or cyber radio frequency takeover capability. And the way that works is that we're able to surgically break the communications between the remote control operator and the drone. And then we go ahead and take control of the drone from the remote control operator, and then the drone belongs to our system. So it's a method by cyber offensive engineering capability that we're able to go ahead and manipulate that signal and surgically sever that communication and then steer the drone to communicate with our system. And the drone thinks it's still talking to its remote control operator and taking direction from where to go and where to land. Once we have that communication signal back to our system, then what we do is safe route the drone out of the dangerous area. And we do that through a series of waypoints. We can go ahead and go above buildings, around buildings, out of the area completely so that we mitigate whatever threat that drone was posing. And then we can safe land that drone in a designated space that we determine is safe for that drone to land. So our system detects drones that are flying in the area, and then we take control of the drone if it's deemed unauthorized, rogue, or a damaging or threatening drone. And then we take it out of that area and go ahead and put it down in a place that is safe for that drone to land. So no kinetic collateral damage, no frequency jamming that disrupts other communications. So our system is ideal for what we call highly populated, dense urban environments, cities, forward operating bases, embassies, stadiums for where we're demonstrating this week. So that's what the system is. And what our system is not is we don't do any jamming. We don't do any kind of kinetic crash, projectile firing, or anything. And an important point to reference here is that we need no line of sight for our system to do what it does. So we don't need to be able to see the drone. If it's anywhere in a large urban environment like a city, we could set the system up on a building and 3.5 kilometers away. Our system, doesn't have to have visual sight of the drone. It will detect the drone, and then determining what we want to do with that drone, we can continue to let it fly if it's authorized. If it's unauthorized, then we can take control of it and safely land it. So the process by which we go through those steps are what I'm showing here on this screen. We call this the kind of kill chain, or the counter UAS kill chain or life cycle, where first our system, in the way we set it up, and I'll show you an emulation of our graphical user interface so you can kind of get a better depiction of what I'm talking about here. But when we set our system up, the system is able to detect drones up to 3.5 kilometers in an omnidirectional type of scenario. That's one antenna configuration that we have. We have other antenna configurations I'll talk about later, but we'll just focus on that and say that for a bubble of 3.5 kilometers, our system can detect and alert all drones in the area that enter into that 3.5 kilometer range. So the system gets a detect and alert notice, and then we start to track and locate where that drone is. And we start like a track, and I'll show that to you here in a second on the graphical user interface. So we're tracking where that drone is flying, and that's in a detection zone at 3.5. Inside that detection zone, though, we also determine what we call a no-fly zone or protection zone. And that's somewhere in the 1.5 to 1 kilometer to 1.5 kilometer that, we're detecting those drones a little further out. But if it comes into that 1.5 kilometer range, we're going to do something with that. So we're tracking those drones as they're flying around. And if they get close to that protection zone, we do something to the drone. And I'll talk about that here in a second. But because there are so many drones flying in the area, and I'll talk about like an airport scenario, for example, there could be construction going on at the airport, there's security going on at the airport where they're using drones, authorized drones, to support those activities. So what our system does is once we locate and track it, we're able to identify the drone as authorized or unauthorized, or identify it as friend or foe. And so if a series of drones have been given to us and their protocols and their identification numbers that are authorized in the area, we can whitelist those drones and allow them to continue to fly, even if they fly into the no-fly zone, because they, again, have been authorized. So we provide in the system a unique identifier for each drone that's detected. And when we see that that's on the authorized list, we whitelist it and let it continue to fly, and then focus on those drones we identify as either rogue, unauthorized, or what we call foe. From that point, we also then want to understand where is the pilot of this drone, and we're able to actually find the pilot with GPS location. So we got the drone flying, we have that detected and tracking that, and then we get a signal of where the location is of the drone operator. If you think about it from a law enforcement perspective, or a border patrol perspective, this is very, very important information and intelligence, which allows them then not only to track the drone and potentially get the drone and the payload, but also get the operator of the drone and arrest him if he's conducting illegal activity. Once we have all that data, the system then says, what do you want to do if this drone enters into the protection zone? We have two options, and everything up until this point was passive listening. The system's not doing anything but other than listening and tracking. But at this point now, we want to do something with this drone because it poses a threat. We can fend the drone off and say, just go back to your home location where you took off from and land there. Or we can take control in the safe land the drone by going ahead and manipulating that signal between the RC, the remote control operator, the drone, severing that communication, and our system taking over that drone communication and telling that drone where to go and where to land. So again, the performance of the system I talked about, we set up a detection zone and a mitigation zone. It detects and identifies up to 3.5 kilometers, maybe further based on the RF conditions or antenna configurations. And then within that safe zone, we have a mitigation or protection zone where the system can either autonomously be set to take over any drone that enters that space, or it can be manually set so that some type of decision needs to be made by an authorized person to go ahead and mitigate that drone, either fend it off and send it back to its home location or take it over in safe land. So I kind of tell you all that to say, here's what the user interface looks like. And I'll go through this quickly so you kind of get a sense of, you're an operator, you've got one of our systems set up right now in an area for which you want to detect and protect against drones. So this could be at a nuclear power plant, could be at a stadium, a military forward operating base, along the border, many different types of use cases and scenarios here. But around the wider side of this, the darker shade of green is the detection zone. And so that is pre-set up by the operator. And that's on the right-hand corner, right-hand quadrant of this graphic user face, which is kind of the mapping section. Inside that detection zone, we have a light green area, which is the protection zone. And I'll talk a little bit more about the lines, the dots, and the other things after I finish kind of the kind of overlay of the user interface. Along the top is our menu board. It allows the user through a touchscreen on a tough pad to set up his protection zones and detection zones, determine if he wants the antenna on, off, if he wants to run it manual mode or autonomous mode, and then gives him some other functions and features about multiple protection zones, wider array of the data, and this is actually where the user kind of interfaces with the system. On the left-hand side in red, orange, gray, and blue is what we call our drone ticket panel. And these are drones that the system has identified and is tracking. And they correspond, those colors correspond to what you see there on the map. So the red drone on top is a drone that we've gone ahead and mitigated, and it's en route right now after being mitigated to a safe landing zone. So that drone was determined to be unauthorized or rogue or present some type of threat. So the system identified that drone and gave us the option to mitigate it, and that is in the process of mitigating. The orange is a drone that we've identified and are tracking but have not yet mitigated. It's given us the mitigate button option, but we've not determined whether or not in manual mode we want to mitigate this drone. The gray box is a drone that's already been mitigated. It went from orange to red to gray and is now on its way to a safe landing zone, and you see the track there. And then the blue paint on the bottom is a Mavic 2 drone, which is an authorized drone that's been whitelisted. And we'll continue to track it, but we've identified it and took it out of the potential threat list, and we'll continue to track and monitor its activity, but we know it's been whitelisted and it's safe and authorized to operate in that space. So what type of drones present the type of threats that we're worried about or concerned about? So there are 5 classifications of drones according to the Department of Defense. And group 1, 2, and 3 are smaller drones. Group 4 and 5 are those big predator and crawler drones that the military uses that are size of small planes. Our system focuses on group 1 and 2 drones, and these are the drones that are easily available to anyone today to go on Amazon, order one of these for $700 to $1,500 to a couple $1,000, have it delivered in a couple days, and there's no background check, there's no certification, there's no pilot requirement. You've opened the box up, put the batteries in, powered up, and you're flying these drones. So easily accessible, affordable, delivered, and no one checking whether or not you're authorized to fly this, and no one verifying whether or not you've been through some training course to ensure you have a safe pilot capability. So the major threats that we've seen and the feedback that we're getting from the customers around the world who are fighting, cartels and drug dealers, bad actors who are trying to get contraband into prisons, terrorist activities that are using drones to carry payloads or conduct intelligence, surveillance, and reconnaissance are what we call the major threat drones, or high endurance drones. They can carry a payload of up to 3 to 12 kilograms. They can travel 4 to 20 kilometers, and the protocols associated with these drones fall into what's known as light bridge or OcuSync or do-it-yourself drones. These are some of the communications protocols, and I provide those there because these are the more difficult drones to take over because of the encryption that's developed when these drones are manufactured. DJI, and that's a Chinese drone company, owns about 90% of the drone manufacturing market. And so they're the most prolific drone company in the world. And you can buy DJI drones on Amazon after our presentation if you like, but they make Phantoms and Mavics, and these are the types of drones that carry the light bridge and OcuSync protocols that are very hard to break the encryption and take over that communication between the remote control operator and the drone itself. But as you can see, some of these drones are quite large. They have cameras, they can carry payloads, and easily accessible, affordable, and kind of the drone du jour or method du jour of terrorists, cartels, and other nefarious actors who want to use drones to conduct their illegal activities. We qualify those as major threats. Now, the minor threats are smaller drones like Wi-Fi drones that don't have the capacity to carry large payloads or fly long distances, but still have all the functionality of the high-endurance major drone threats from a camera perspective, or the ability to conduct some nefarious activity, illegal activity, and are also what are included in our drone library of drones that we're able to actually capture with our system, take control, safe land. I think one of the last slides I hear is to talk about the system itself. So you saw in the video there's a tripod, there's a pizza box, and there's a couple of antennas that I'll talk about here that go on top of the system. But that's the form factor of the EnforceAir system. Very simple, very lightweight, packs up in 3 Pelican cases. It can be assembled by one person in 5 to 8 minutes. The brain behind the system is that box in the middle. It's called our software-defined radio, SDR. And that's where all the hardware, software, firmware interacts and allows us to conduct the activities that we're able to do with those types of drones that I showed you in the previous slides. The system is mounted on a tripod if you want a fixed or static site, and then it can be mounted with different types of antennas. So I'll go out from the middle to the left and right. The white antenna, we call the cupcake, is a radome antenna, and that provides a 365-degree omnidirectional coverage area of 3.5 kilometers for detection and about 1.5 kilometers for mitigation. And that, again, assembles in 5 to 8 minutes. It can be disassembled if the threat is moved and an agency needs to move to a new area and reassembled. So it's the standard tactical solution that we provide. The black antennas, the cylinder antennas to the right of the SDR, it might be the left if your screen is backwards or mine is backwards, are what we call our high-angle folding antennas. In this configuration deployment option, these antennas provide a greater range of north and south latitudes of up to 40 degrees. So with this antenna configuration, the optimal scenario for this deployment is in a highly populated urban environment where Drones are flying below buildings and above buildings, or below where the system sits, and the system can detect both up 40 degrees, down 40 degrees, and cover drones in both the above and below type of threat scenarios. Those antennas fold up quickly. Again, a 5 to 7 or 5 to 8 minute assembly, disassembly for that, and is sometimes used in conjunction with the radome antenna. I'll go to the white vehicle, maybe on the right or left, and that's known as our covert vehicle kit, where the antennas are those four black cylinders on top of the vehicle. Those are magnetically mounted, and the SDR, the software-defined radio, is mounted in the back of the system, and the tablet for interface is mounted either on the back of the headrest or on the window with suction cups, and you then have this capability on the move. It provides that same 360 omnidirectional coverage, but it's now mobile. So you can drive around perimeter fences and boundaries and have that type of 360 bubble capability. It can be deployed in conjunction with a ground level tactical system, so that it provides beyond the 3.5 coverage, area coverage while it's being driven around. We also, next to that, have a military vehicle configuration where the cupcake antenna is mounted on an M-Razor or some FLMTV, or other types of military vehicles to provide that military functionality on the move like we do with the covert kit. Going over to the other side are two other antenna configurations. The white fins are our long-range directional antenna. These antennas provide 7 to 9 kilometer coverage for detection and 4 to 5 kilometer coverage for mitigation. These antennas are ideal for airport scenarios and border scenarios where we deploy the antennas at an airport on the inbound-outbound corridors for flights, and at a border wall in each direction, back to back, to provide 7 to 9 kilometer coverage along the border wall, where they might also have a ground level tactical system at a border crossing, and then an on the move covert vehicle kit to provide them mobile coverage in a combined scenario. And then the last antenna configuration deployment option is what we call the high altitude stationary, where it's the same high altitude tactical antenna you see on the mounted system next to the SDR, but this is a fixed antenna configuration on a building or a pole, as opposed to being mounted on a tripod with the SDR. So a lot of flexibility, a lot of adaptability and agility with what we're able to do with configuring the system, deploying the system to meet whatever mission requirements or mission needs or operational needs our customers have. So kind of closing here, what we really like to foot stomp and say, differentiates us from our competition, beyond the fact that we're not kinetic, we're not jamming, and we don't need line of sight, is that our system is future ready, and we're always updating the system with new protocols and new drones that are rolling off the manufacturing line. The D-Fend EnforceAir system is a library-based system, meaning that inside our systems we have about 100-ish, I can't say exactly because it's our IP, types of drones and drone protocols that we have successfully figured out how to detect and mitigate. Now, there are drones out there that we don't mitigate or detect, but what we did is identify what are the most prominent types of drones conducting the most nefarious types of activities based on feedback we're getting from customers today around the world that are presenting serious threats to their continuity, their mission, their operational requirements. And those are the drone protocols and drones that we have in our library. But those experts in Israel that I talked about, those folks come out of military environments and backgrounds that are along the lines of signals intelligence, offensive cyber, reverse engineering, protocol manipulation. And these guys and gals there, who I think the average age of the company is about 24 years old, which makes me feel kind of old. They are experts in the ability to manipulate quickly a new drone and drone protocol and assimilate it into our library so that we're able to get that update out to our customer quickly, so they've got the latest and greatest capabilities against what the adversaries may be thinking about using as a new drone and new drone protocol. So the system updates and releases updates to customers on a quarterly basis, or if a customer has a pressing need, we get right on that. And our time from new protocol being released to actually fielding that capability is somewhere between 3 weeks and 3 months. So our guys are great at guys and gals are great at this. We get a lot of positive feedback from the operators in the field, but what we're also very good is assimilating that feedback into what is the next iteration of capability that we need to roll out for our customers and then be rapidly responsive. So that is what I have today with regards to all the slides. Happy to go into questions and answers if we got time right now. But that's our system. Thank you for listening to me, and I'll turn it back over to you, Danny.
Awesome, Terry. Well, it looks like we got a couple questions here. We have 4 so far. I'm sure a few more will roll in. First one here, can you speak about the detection-only system?
Yes, absolutely. So our system can be sold and configured to only present detection functionality to the operator. It can be hard-coded to prevent any type of mitigation. And so we have a different type of system development process for that, so that that mitigation functionality is not even included in the system that we would deploy to that customer. Now, if later that customer is able to actually mitigate, if laws and regulations and authorities change, then it's just a change we sent out as a software update to the system. One of our engineers shows up and does a little bit of configuration management on that, uploading it. But we do sell the system as a detect-only capability. In fact, that's been one of the major requests for non-federal government customers in the critical infrastructure space, the airport space, the stadium space, because they're not authorized to mitigate as the laws and regulations state today.
Perfect. Next question here. This was during the time when you were discussing, or you had a slide up of all the different color-coded pathways. And the question was, does the drone do all this? Does your drone do all this work? Which I believe they're referring to the system itself, kind of mapping all that out automatically, or how much of it is user input?
So no, the system does all that. The operator, when setting the system up, after he assembles it, 5 to 10 minutes after that, he then takes his tablet out and he sets his detection and protection zones. And so those are polygons that he can set up. He can set up multiple detection zones, multiple protection zones. He can deploy several sensors and have them feed into what we call our multi-sensor command and control system. So he's monitoring multiple sensors. And again, all he sets is his detection and protection zones, and either sets the system to autonomously mitigate or manually mitigate. But as a system is turned on, as soon as the drone is fired up, in many cases, before it even takes off, as soon as the drone is fired up and turned on, the orange detection bar comes on, that a drone has been detected within that range. It then gives you the type of drone, the protocol, the distance, GPS location, and then it starts to track that drone with an orange track. Now, if another drone is powered up and that drone is along the line and we determine it's one of our authorized drones, then we whitelist that, and then a blue tab is set in the pane, in the drone ticket pane, and a blue track. But the system does all that based on the operator configuring the system before the actual operation. So very intuitive. It's a 3-day training course on setup, operation, troubleshooting. And it was designed for, simplistic field use. So not a long, intensive training process, not a lot of certification required. So the system does all of those things and color codes everything based on the operational scenarios set by the operator. But again, pretty simplistic. This is my detection zone. This is my protection zone. I'm going to set it to autonomously mitigate, or I'm going to manually mitigate and get that mitigate button. But every orange drone that pops, or every orange ticket that's generated, is a new drone that's been identified by the system, and then it moves through the process. If we mitigate it, it goes to red while it's being mitigated and reprogrammed, and then once it's taken over and sent to the safe, through a safe route to the safe land, it goes to gray, and then again, the blue is a whitelisted drone.
Perfect, thank you. Next question regarding how do you get around the legal issues created by the functionality of the system? I think we talked about this a little bit, but.
So, it has been a challenge. We're not trying to get around anything. So let me just put that out there first. We're operating within the construct for which the Department of Justice has said these types of systems can operate. So federal government agencies in a law enforcement, border patrol, homeland security, national security type of role have the authorizations to conduct both detect and mitigate, functionality. I'm going to take a sip of water here. I'm doing a lot of talking. There was guidance issued by the Attorney General last April that said federal officers within the Department of Justice in the grade of GS-15 or above have the authorities to mitigate drones. There's discussions around whether this is a Title III type of wiretap function, and that's why it requires federal law enforcement approvals. There's also concerns around privacy on what is the system like ours, or a system that's doing, protocol manipulation, what type of private information is it getting off of the drone remote control operator of the drone? And the answer that we provide is we don't get any of that. We get GPS location, lat long, and then that ability to manipulate that packet or so that we use to take control of the drone. So we're not trying to get around any authorities. What we have done with stadiums, nuclear power plants, other critical infrastructure assets who don't have an FBI agent or a Department of Justice agent in GS-15 or above grade at their location is develop a network solution back to where an operations center does have an agent at the GS-15 grade or above. And in real time, when the detection is happening, it's also feeding back to this ops center. And if that drone enters the protection zone, then an alert is sent back, and then an authorized, trained GS-15 or above grade law enforcement agent can make the determination whether to mitigate it or not. So a network solution is available for that type of scenario. But that's why, to the previous question, we are selling it as a detect-only capability. But, we're not ambulance chasers. Unfortunately, though, sooner or later, or when, not if, a drone takes out a commercial airliner or crashes into a stadium or, God forbid, releases some type of nefarious or chemical, biological, payload, those authorities are going to extend down to state, local law enforcement and other security professionals are responsible for protection of critical assets, stadiums, you name it, what they might have. But as it stands today, there is a limitation on the mitigation piece. But because of the robustness of the system to detecting and then being able to kind of manage the risk of what do we do now that we know this drone is flying around, maybe then there's a call to the local FBI office for someone to come check out what they might need to do to mitigate it if it becomes a threat.
Perfect, thank you. And in that same vein, we've got a question in the chat that says the FAA made a ruling lately. It sounds like the requirements for rec drone users is going to be vastly changed with broadcast ID. Will this change the effectiveness of your system at all?
No, in fact, it's going to enhance our system. So you're talking about remote ID. And so we've been anticipating, this ruling from the FAA. And so our system has been designed to be ready for whichever way they pivot and decide on how they're going to implement this. It'll be a time before any counter UAS system today is actually able to integrate remote ID into its system's functionality. But our system was designed to be adaptable to what we believe is, the couple of ways FAA could go with requiring remote ID for registering all drones that are purchased by consumers. So it's actually going to enhance the drone ecosystem. It's going to enhance the protection of society from potential drone incidents. But for us, it makes our job a lot easier because we do use those identifiers and are able then to, I think, assimilate whichever way the FAA is going to go with remote ID into our system.
Perfect. And then a follow-up on the legality question. So you're not, quote unquote, hacking the data packet sent by the drone. And are you getting the drone serial number?
So no, it's not hacking. So we don't say it's hacking, but we are able to manipulate the protocols. And so it might be conceived or perceived as hacking, but it's a very short burst. We get necessary data, telemetry data, GPS data, remote control operator location, drone location, and we get information about the drone, type of drone, serial number of the drone, and then we translate the drone identifier to our unique identifier. So that way, a scenario where, with a Border Patrol test and evaluation event, a live drone was flown over a 3-week period from the other side of the border conducting ISR, intelligence, surveillance, reconnaissance. But because we tracked that drone and gave it a unique identifier the first time we identified it or detected it, every time that came back and forth, that drone popped up again as this is that same drone with our unique identifier. So it's protocol manipulation. It's a small, surgical bite, if you will, that we take to get the essential data that we need. And then we're able to control the drone and sever the communication with the remote control operator. So hopefully that answered that question.
Perfect. We've still got a couple questions rolling in here. Can the system survive in a saltwater and high moisture environment, and could it be used on shorelines and or vessels? So
yes, we have a maritime deployment option where it's been tested on both on more small boats than larger boats, where it has been covered by a wave, saltwater wave. It's mil standard. It's been tested against specific military standards, and I can get you those test results and those mil specs. But yes, it has been tested in a maritime environment, specifically with that type of scenario for waves coming over a small vessel who's doing border type of protection and security.
Perfect. And then we've got two more so far here. It says, you mentioned that your system detects the connection between the drone and the user on the ground and takes control of that connection. What if the drone is operating autonomously without a ground operator? Can your software still seize the control of that drone?
Great question. And it's one we feel quite often because the drone technology is evolving at a rapid rate. And so we are working on autonomous drones to assimilate to our library. We don't have the capability yet. And I say yet. But it is something that all of our customers come to us saying, hey, this looks like this is the next step in drone technology development, and is going to be ideal for our adversaries, the guys that we're trying to chase and those that we're trying to protect against, to utilize to evade this environment or this type of system that we're using. And this is really kind of a cat and mouse game. So as we develop risk mitigation capabilities, nefarious actors and bad people and the terrorist groups, they're always looking to, work around or evade those types of countermeasures. So, as new drones capability comes out, we have to keep pace with, how is our system going to effectively provide the same detection and mitigation functionality if there's no remote control operator and the drone is flying autonomously. And there's still got to be something that we're able to detect. So our folks are working on that. It's definitely in our roadmap, but it's a tough challenge. And I'll say that about this whole process. This is very hard to do. That's why there are very few RF cyber takeover and safe land counter UAS companies. A lot of jammers, a lot of kinetic solutions, but very few RF cyber takeover and safe land capabilities because it is so hard. So I offer that up as an answer is that not yet, but we're working on it, and we're also looking at what else might be coming down the pike to again evade the countermeasures that our system provides. Just an example of something that just rolled off the DJI manufacturer line is a new drone they call FPV. It was rolled out last week. You wear goggles to operate it. It's a joystick kind of. It's crazy. That's already in our library. It just rolled off the manufacturing line about 2 weeks ago. So that's a kind of capability in-house that we have to keep pace with this very prolific market.
Awesome. Next question: does it only work for aerial systems, or can it be used with unmanned ground or surface or water systems?
It's a counter UAS, counter drone system. That's our expertise. That's our sweet spot, and that's what we focus on.
Mm-hmm. Perfect. And then looks like last question for now, unless we get any more popping in. How large of a power source is required for the system for both a mobile and stationary system?
Very little power. We run the system off a generator where there's no shore power or battery pack, 2940 batteries. We have a white paper that provides all the technical specifications that you can get from your Federal Resources account representative, but a low amount of power needed or required to operate the system. The covert vehicle kit can be run off the cigarette lighter adapter, so that can generate the power to power the system, or it's a Bentronics battery pack with 2940 batteries that are swappable to provide multiple hours of coverage, but low power source requirement to operate and maintain the system.
Perfect. All right, well, that's everything in our queue. I'll do one last call for questions here. A lot of good questions. I appreciate the feedback from everybody. I think we're all good to go. If you do have any more questions, you can certainly follow up with the person, your Federal Resources account rep. But Terry, we appreciate the time. It's a fantastic overview, and we're looking forward to working more with you in the future.
Sure. And one last thing I'd like to say to everyone is thank you for your time. Please reach out to your FR account rep. They've got some of our market material, our technical specifications and white papers. And I also like to add, as Danny talked about earlier, we are conducting in the Washington, D.C. area on March 30th, Tuesday, March 30th, a live system demonstration. It's in Benedict, Maryland. It's about a 2-hour event, but you'll see us fly multiple scenarios, including swarms, where our system has been tested up to 12 drones coming in from north, south, east, and west and detected and mitigated all. We'll do that scenario. And then we'll do covert vehicle kit and several other scenarios. But again, March 30th, Tuesday, in the Washington, D.C. area. You can also get more information on that from your FR account rep. Thank you all for your time. It's been great talking with you. If you need more information, please hit the D-Fend website, www.divittorio.com. d-fendsolutions.com. Had to give the plug. Or you can get to me through LinkedIn or other source. But thanks again, everyone. It was a pleasure talking with you.
Great. Thanks, Harry. Thanks, everyone, for joining. Have a good one.